Well, now let's take a look at the third topic here on the skills check. Our third topic is going to be, can I write out the equations of some different lines? Now, fortunately, this is one thing that we practiced already in the last set of sections, but it doesn't hurt to kind of recover those ideas here. Of course, we already know now that we need a point and a slope in order to create the equation of any given line. However, I should notice that sometimes I might be given a question where I have to calculate my slope not via a derivative, or maybe not by using two separate points, but by taking a look at whether I have an equation that is perpendicular or parallel to some other sort of equation. Remember that if I have lines that are parallel, parallel lines ultimately have the same slope, and perpendicular lines ultimately have what we would commonly call opposite reciprocal slopes. That is, if line 1 had a slope of 1/3, the other, or well, let me write it like this. If one line had a slope of 2/3, the other would have a slope of -3/2. So I kind of take that fraction and I flip it. So this is the idea of these sorts of lines. So if I was to go ahead and take a look at something, maybe like 3b, I could see the following. I want to find the equation of a line that passes through the point 1, 5 and is parallel to the following line. Well, notice that I already have here a nice point that I can make use of, which is 1, 5, so that's nice. And if I want that slope value, I might just quickly have to think about the line that I'm working with right here. If I want to see the slope of that line, it might be helpful to get this into that slope-intercept form by adding the 5x to the other side. I can then see the slope is the value of 5, and so I can put this information together to write the equation of my line. Y minus 5 is equal to 5 times x minus 1. And so now, if I wanted to get this into a slope-intercept form, I'm perfectly okay to do that. It seems like here I would end up with a line that is going to be, let's see, I'm going to have a minus 5 here, and then I'm going to add 5 over. So it should just be y is equal to 5x. So this is how I would actually deal with, again, a problem where I'm trying to create the equation of a line and I'm given some information about the slope either via parallel or perpendicular lines. Now really quickly, if I was to go ahead and also take a look here at part A, we could see that in part A I'm not given any other line, but I'm just given 2 points. And so that should be pretty easy to do in terms of writing the equation of a line that goes through them, because if I want to calculate my slope, I just can go ahead and do a difference between my y's, difference between my x's, and calculate the slope in the standard way. So notice here, if I did a change in my y coordinates over a change in my x coordinates, I'm going to end up with, let's see, 9 over 0. Wait a minute. 9 over 0? Wait, that would make this slope here undefined, right? And if my slope is undefined, then I probably have a line that ends up, at least graphically, being a vertical line. So let's go ahead and take a look at our points again. Notice I had the point 1, -2 and 1, 7. Yeah, I had a point here and a point like up here. So if I wanted to figure out the equation of this line, it would actually be really simple. I recognize that this is a line where all the points on it have the same x coordinate in common. And so lines that have the same x coordinate in common can be written as an x equals formula. So here I would have only points with x coordinate of 1. And so here I have a line of x equals 1. I'm going to leave part C for you to go ahead and try out on your own, but hopefully with what we've done here in parts A and B, you should feel pretty comfortable with tackling questions like these.